Welcome back to my channel, and today we will together solve the problem of maximum matching of players with the trainers. And so in here, like, we are given two arrays. The first one is for the capacity of the players, and the second one is for the capacities of trainers. And so in here we will match the trainers with the players under the condition that the capacity of the trainer is greater or equal than the capacity of the player. So in here, like, for example, we are given the list of the trainer, which is the 8, 2, 5, and 8, and then we need to match these trainers with the list of the players, which is 4, 7, and 9. So we can see that somehow, like in here, like, so we can match the 4 with 5, 8 with 5. So it means that this player, in there we have two choices, and this player, or we have two choices. So I will change the color in here to better illustrate. Okay, so here, like, we have the better illustration, demonstration. So in here, like, this one can be matched with this 8 with this trainer or this trainer, right? So it means that, like, we at max we can have two pairs of the players and the trainers. So here, like, okay, so in here, like, we can, okay, so how can we come up with the solution for this problem? So firstly, we need to sort this one first. 8, 8, and this one is 4, 7, and the 9. So we always compare the last element of the trainer and the last element of the player to see. Okay, so for now, if we want to compare them, because, like, we always want to match the trainer with the players, and that player is expected to have the highest capacity. And then if we can match this one, and then it means that we can we can prioritize this case. Otherwise, we need to remove it. Okay, so in here, like, we for example, like in here, I have the trainer. I have trainer here, right? And then so I need to compare with the highest capacity of the player. So in here, that is the 9. So we have two cases. The first one is like the trainer have greater or equal to the capacity of the player, right? So how can we deal with this case? So in here, like, we just need to remove this one and remove this one. But of course, this case, like, it doesn't work in this, because, like, 8 smaller than the 9, so we cannot remove it, or, like, we can count it by 1. But in here, like, it have the another cases, like, what if the trainer smaller than the player capacity. So in here, like, of course, like, we have no trainer can match to this player. So that's why we need to remove this player, and then we move our point to the next point. So in here, move to the next player. So when we move in here, so we can see that this condition is satisfied, and then we move both of them out of the list, and then we count it by 1, and then we move the next point, right? Okay, so in here, it means that when the trainer greater or equal to the player, and then we can remove it. We can remove this one, or just move the pointer to the next element in the array. And the array, we need to work with the sorted arrays in this case. So here, like, we will remove, and this one is like, we can count by 1, and then we can move pointers, right? In here, like, we can move the pointers. Okay, so let's implement this using the algorithms. And what if in this case, what if the trainer is smaller than the player? And then, of course, like, we just move the pointer for the player, right? We move this here. Okay, so let's implement this together. Okay, so here, like, firstly, we need to sort the player, sort the trainers, and then what next? So in here, like, we need to define the answer, that is the count, because we count about the pair, so that is the 0. And then, so I will use the while loop in here. If the length of the players greater than 0 and the length of the trainers greater than 0, and then it means that like we haven't created all the matches for the players in the trainer. And if the trainer, we compare the top, right? So this one is very similar to the queue, the max, the prioritized queue, and that is the priority queue, and that is the max heap. So you can think about using the max heaps as well. But in this case, I think that the iteration is like it is faster, right? If the trainer has greater or equal the capacity of the last players, and then we will move the both pointer, and then we increase count by 1, and we pop the last element and the players. In here, like I choose to decrease the pointer. I mean that I want to move the pointers by using the pop element, because like I always compare the last element or the highest capacity of the both trainers and the players. So here like I just use it. But it depends. You can choose to move the pointer instead. And then so in here like we use the player pop, because like we only remove the last element, right? Then in here we can return the count. Alright, it looks good. Okay, so in here like we have already solved this problem, and this problem is very similar to the assign cookies. And so let's solve this problem as well. We have the assign cookie here. Okay, and then so for now we can put the players as the G, and the what is the last one? So we have the trainers, right, at the S, because like the definitions up in here like just in different kind of the like notations, so we just need to change it. Okay, cool. So we solved both problems. All right. Okay, so I hope that this video is useful for you in solving 2 problems. Thank you. Thank you for watching my video, and if you like, and you can give me a subscribe to give me motivation to do more videos and explain for you about the algorithms and prepare for you to the coding interview to the companies. Okay, thank you so much for watching my video. See you next time.